Space is full of weird places, and honestly, you don't even need to leave our own solar system to see that. We've got dry rocky worlds, giant balls of gas, planets boiling on the surface, and others frozen solid. Some have rings, some have dozens of moons, and some have storms bigger than entire planets. But once you step outside our little corner of the galaxy, things get a lot stranger. As of mid-2026, astronomers have confirmed more than 6,300 exoplanets, with thousands more candidates still waiting to be verified. Some of these worlds look a bit like the planets we already know. Others are almost impossible to imagine: skies with 2 or 3 suns, rain made of liquid metal, planets bigger than the stars they orbit. So today, let's tour some of the strangest exoplanets we've found so far and a few of the mysteries that are still waiting to be solved. Let's start with something simple. How long is a year on other planets? On Mercury, a year lasts just 88 days, the shortest in our solar system. Strangely, a single day on Mercury sunrise to sunrise takes about twice as long as that. So technically, 2 Mercury years pass before you'd see one full day-night cycle there. Now compare that to exoplanets. Most of the ones we've discovered have incredibly short years, often just days or weeks. That's not really a coincidence. Our main way of spotting exoplanets is the transit method. We watch a star closely and look for a tiny dip in brightness whenever a planet passes in front of it. To confirm it's really a planet, we need to see that dip repeat on a regular schedule. If a planet takes years to orbit its star, we'd have to wait years between each dip just to be sure. So naturally, planets with short, fast orbits get discovered much more easily. The record holder for the shortest year goes to an object orbiting a pulsar, the crushed core of a dead star, completing one full lap in under 49 minutes. If we stick to planets around normal, living stars, the title goes to K2-137b, which zips around its star in just over 4 hours. It's so close to its star that it's basically doomed. Eventually it'll either be torn apart or pulled in completely. On the flip side, the longest known year for a planet-sized object is roughly 1 million years. And if you want to go even bigger, there's the idea of a galactic year, the time it takes our whole solar system to orbit the center of the Milky Way. That's about 250 million years. Doing the math, Earth is only around 18 galactic years old. In cosmic terms, we're basically teenagers. Here's something else that breaks our usual assumptions. Not every planet orbits just one star. Many star systems in the galaxy are actually binaries, 2 stars locked in orbit around each other. Some systems have 3, 4, or even more stars, arranged in stable, layered patterns so gravity doesn't fling anyone out into space. And yes, planets can orbit these multi-star systems. Depending on where a planet sits, it might only see one star, or it might circle the entire group and technically have several suns in its sky. In a 7-star system, for example, a planet on a wide enough orbit could have all 7 stars visible, though from that distance, they'd look tiny and give off barely any warmth. The first real multiple sunset planet we found was Kepler-16b, spotted in 2011 and nicknamed the Tatooine planet after Star Wars. It isn't a desert world at all, it's a gas giant roughly a third the mass of Jupiter, orbiting 2 stars at once. Since then, several more of these Tatooine-style planets have turned up, which makes sense once you realize that more than half the stars in our galaxy actually have a companion star nearby. So what would it actually be like to live under 2 suns? If Earth had a second, smaller star nearby, our year would shrink, our seasons would go haywire, and we'd deal with far more radiation and solar flares than we do now. Swap that smaller star for something like a blue supergiant, and forget it, nowhere in that system would be safe to live, partly because giant stars tend to end their lives in supernova explosions, which would sterilize anything within many light years. Not every planet has a star at all. Rogue planets drift through the galaxy completely untethered, either kicked out of their home system early on, or formed on their own and never grew big enough to become a star. We think there could be billions of them scattered across the Milky Way. Finding a planet that gives off no light of its own sounds almost impossible, and it would be, if not for a clever trick called gravitational microlensing. When a rogue planet happens to pass in front of a distant background star, its gravity bends and briefly brightens that star's light, like a tiny lens. Astronomers watch for that flicker to confirm a rogue planet is there. This method is so sensitive it can even catch planets as small as Mars. Upcoming missions, including NASA's Roman Space Telescope, which launched in 2026, are expected to scan huge patches of sky for exactly these kinds of events, and scientists hope it could reveal far more rogue planets than we currently know about. What might it be like on one of these worlds? Total darkness, for one thing. But surprisingly, not necessarily freezing cold without a nearby star. There's no solar wind to strip away an atmosphere, so a rogue planet with a thick enough atmosphere could actually trap heat and maybe even keep liquid water going, powered by leftover heat from its own core. Now for something genuinely bizarre, WASP-76b, a gas giant bigger than Jupiter that completes an orbit in under 2 days because it sits so close to its star. That closeness makes it viciously hot, around 2,400 degrees Celsius on the side facing the star, hot enough to vaporize metal. Using an instrument on Europe's Very Large Telescope, astronomers found iron in the planet's atmosphere. On the scorching day side, iron literally boils off into gas. Strong winds carry it around to the cooler night side, where temperatures drop enough for that iron to condense and fall as rain. By the time it reaches the morning side of the planet again, the iron has vanished from view, presumably locked away in the deeper atmosphere. As extreme as WASP-76b sounds, it's not even the hottest planet we know of. That title belongs to KELT-9b, a gas giant nearly twice the size of Jupiter, orbiting a blazing star nearly twice as hot as our Sun. Its dayside temperature has been measured at around 4,300 degrees Celsius, hotter than plenty of actual stars. The heat is so intense that molecules on KELT-9b's surface get ripped apart, and its atmosphere is slowly boiling away into space, dragged back toward the star at a staggering 100,000 tons of hydrogen every second. Eventually, its atmosphere may vanish completely, exposing the bare core underneath, assuming the planet survives that long before its star expands and swallows it in a few 100 million years. Can a planet be physically larger than the star it orbits? It sounds backwards, but it's possible, because big and massive aren't the same thing. Neutron stars, for example, can pack more mass than our Sun into a ball only about 30 kilometers wide. White dwarfs, the leftover cores of dead stars, are also tiny, often no bigger than Earth. Any planet that survived orbiting one of these collapsed stars could easily end up larger in size, even while being far, far less massive. One confirmed example is WD-1856b, a planet found in 2020 circling a white dwarf. Remarkably, it appears to have survived its star's dramatic transformation from a normal star into a red giant and then into a shrunken white dwarf, a phase that should have destroyed anything orbiting that closely, meaning the planet likely drifted into its current orbit sometime after the chaos settled down. As for the single largest exoplanet ever spotted, the current best guess is GQ-Loopy b, estimated at roughly 3 times the width of Jupiter, though there's enough uncertainty in the measurement that it might actually be a small brown dwarf instead of a true planet. Let's finish with maybe the most visually stunning candidate of all, J1407b. Ring systems are surprisingly hard to detect. We didn't even confirm Uranus had rings until 1977. But when this planet passed in front of its star back in 2012, it blocked out an incredible 95% of the star's light, far more than any known planet or ring system should be able to do. The likely explanation: a colossal ring system, one that would dwarf Saturn's by more than 40,000 times in surface area, big enough to stretch out roughly as wide as Venus's orbit around our Sun. There's a catch, though. J1407b is supposed to orbit its star roughly once every 10 years, but no one has seen it repeat that dramatic dimming since. It's possible this was a one-time event, maybe a free-floating object with its own disk of debris that just happened to drift past, or it could still be orbiting normally, with rings thinner than first thought. Either way, scientists are still watching closely. From planets with 7 suns to ones that rain molten iron, from lonely wanderers with no star at all to a possible ring system wider than a planet's entire orbit, our galaxy keeps proving that reality is stranger than anything we could invent. And with more than 6,300 exoplanets confirmed already, and thousands of candidates still waiting to be checked, we've almost certainly only scratched the surface of what's out there. What's the strangest exoplanet you've heard of? Let me know down in the comments.